The autoflight system is divided into four main parts, as you can see here. The flight management part, the flight guidance part, the flight augmentation part, and the fault isolation and detection system fault. I'd like to tell you here the way I quickly distinguish the difference between flight management and flight guidance. I would say flight guidance is what Airbus describe as short-term navigation, which is if you're looking at an ADI, it's up, down, left, right. It guides you for immediate short-term navigation. So up, down, left, right, which is your ADI, which is your sky ground picture. And flight management uses the FMS for long-term navigation from A to B. So those are the two differences. I consider as short-term navigation, long-term navigation, and that's how Airbus defines it as well. So these are the four different systems that the four different units or topics we're going to look at in terms of the autoflight system. So we have two sets of computers, the flight augmentation computers, and we'll look into them in a minute, and the flight management and guidance computers. So you can see just the word, it does short-term and long-term navigation as it does flight management and flight guidance computers, and they're basically the flight control computers for the autopilot system. So here we can see the auto thrust is part of the autopilot as well. So if you are a Boeing person, you may have heard of the term auto throttle, whereas Airbus used the term auto thrust. Auto throttle is a Boeing patent, and Airbus they're still not allowed to use it. There are a lot of systems that are patented through various OEMs, manufacturers. So the Boeing, the first MCP or the autopilot, what the 737 had, was built by Honeywell, and then Honeywell was the patent holder of the automatic throttle system, which Boeing had, which is a moving throttle. So you will actually see the throttles move, advance and retard as during flight, where it was a Sperry. It was a Sperry auto throttle system. At some point, Honeywell bought Sperry, and Honeywell was the main supplier of all Boeing avionics equipment. So the auto throttle became a Boeing patent. When Airbus came along to determine a auto throttle system, they weren't allowed to use. They could use a similar design, but they weren't allowed to name it auto throttle. So they named it an auto thrust system, which is basically the throttles are non-moving. So the pilot will take the throttles and move them to the takeoff thrust. The aircraft will take off or MCT, max continuous, take off, and at some point the pilot will get an indication to take the throttles and put them into the climb detent. And as the pilot puts them into the climb detent, the auto thrust is then active, and then it remains active for the remainder of the flight until the actual aircraft lands, or just before landing, the pilot is asked to retard the throttles, and he hears the command retard, which means take them out of the climb detent, put them in the idle detent, and that's when the auto thrust then disconnects on an Airbus. Throughout the duration of the flight, from the climb detent, the auto thrust is engaged until the pilot physically takes the throttles and moves them out of that climb detent. So the throttles throughout the duration of the flight, even when the engines spool up or spool down, they are completely independent of the throttle positions managed through computers, through the FMGCs in a different way than the Boeing ones. As we can see, it's all fly by wire, all interlinked with the FEDEC, which is the brains for the engines, basically. So they get commands to increase or reduce the thrust, or to put more fuel into the engines and produce more thrust. But the throttles themselves do not move throughout the duration of the flight. So we use the throttle, the engine thrust, to increase the speed of the engines and thus pitch up or down. We can also use the flight controls, where we use the side sticks to be able to roll the aircraft. Okay, so that's the two ways we do it for the automatic flight for short term, and also for long term from A to B. Here we have a little flight plan here, which we pre-program before departure. And the automatic pilot or the human pilot follows that flight plan from A to B. Okay, so the flight management part has got several functions linked to the flight plan, such as lateral and vertical navigation, or vertical guidance, associated with performance computation. So we can, the pilot actually does do this. They get all the information before the flight. They have their briefings. They say, all right, I'll give you a pure example. I'm going to fly from London to Munich. Okay, I'm going to take off in London. I'm going to before I even take off, I have to put in all the runway length of the runway I'm going to take off, which runway I'm going to use, how long is it, how heavy my aircraft is, so I know how much thrust I need to get off the runway. The length of the runway determines how quickly I have to get off. So it depends on my weight. So all these parameters get put in the computer, and the computer then determines what your V1 is, what your V2 is, what your V rotation is, how far down the runway you're gonna get wheels off, okay, and how much space you'll have, how much length you'll have if you, for example, have a rejected takeoff. All these parameters are collected, put in the computer, and then the computer will then make me a long-term flight management plan, okay, which I can manually insert it, or if I have a nav database which is active and valid, then I can, and there's one that's available, the pilot can select it, okay, and select from A to B. I'm going to fly from London. I'm going to take runway whatever. I'm going to climb to 28,000 feet. I'm going to take a southwesterly direction. I'm going to fly over Paris, and then at over Paris, I'm going to be at 39,000 feet, because that's what everything's pre-programmed. And then at I don't know, 74 minutes in the flight, I will take a right turn, and I will descend to 28,000 feet, and so forth, and so forth, and so forth, from takeoff up into the retard command I get just before or at landing. Okay, all of that happens automatically, and that determines the long-term flight management side from A to B in the most economic way. Okay, now the indications I put on predominantly on my primary flight control for flight guidance, but this I use for flight management because it's from A to B. I can see here, remember we said last time I can set my range to a different range and see the whole flight in front of me as it evolves and as it emerges automatically from the FMGCs databases and also from what I have selected as a flight plan. Okay, so the flight management guidance computers, you see they have two distinct definitive functions. The flight management plan, which is A to B in a lateral and a vertical manner, and flight guidance, which is up, down, left, right, and is immediate, and is used for the autopilot, for the flight director, and for the auto thrust. In terms of the flight director, what is the flight director? The flight director is an app which basically takes all the calculations and gives the commands using command bars, gives the commands to the human pilot or the automatic pilot to follow. That's what the flight director is. So this is an app within the FMGC, which takes all the parameters, all the sensors from the aircraft, the inertial systems, the radio nav systems, passes them on to the flight guidance system of the FMGC, and then puts them into use. And when we said we're going to fly from London over Paris, turn right at 37,000 feet and descend and all that, the flight guidance, the flight director puts the directors up, which is usually some lines like this or an airplane symbol, depending on what's selected, which the pilot, the human pilot or the automatic pilot have to follow. In terms of auto thrust, we already said the engines are managed by computers, by a FEDEC system, a full authority digital engine control. Okay, so they spool up, they increase and reduce in power, which means the fuel control unit will get more fuel or less fuel depending on how much the demand is on it. And the demand on it depends on what is requested from the current situation. If we're taking off, for example, we're on the end of the runway and we're doing a takeoff, then we want maximum thrust. Then the auto thrust will then tell the FEDEC, Mr. FEDEC, I want put the maximum fuel in the engines, and the engines will spool up without the thrust levers moving. Okay, so once they moved into the takeoff thrust, yeah, the engines spool up. We're talking the auto thrust system is in the non-moving situation, where the throttles are in the climb detent after the auto thrust is engaged and active. So the engines will spool up, so the engines will get more or less fuel from all the systems, regardless of the throttle position, which will not be moved until the pilot has heard the command to do so, to retard either just before or on touchdown. Okay, all this is arranged through the flight management and guidance computers to tell the engine interface units to tell the FEDEC more fuel to maintain a certain thrust position.